Hi, IoT Builders. We're back live from Embedded World 2023. And I'm here with Lian from Sternum IoT. Really excited for the next session, which is going to be around embedded security, embedded runtime security, and continuous monitoring. So, hi, Lian. How are you doing?
Okay, how are you?
Very good. So tell us what you do and what is Sternum IoT.
Sure. So I introduce myself. My name is Lian. I'm the co-founder of Sternum. Maybe I'll tell a little bit about myself before talking about my company. Okay, so I started my technical background in Unit A200, which is the NSA's equivalent in Israel. So I did a lot of cybersecurity and low-level development. And after that, when I joined the market, I went to work as a security researcher, understanding how the Android system works. And there I met our CEO, Natalie. She actually was also in an interview here about a week ago. And together and with some other partners, we founded Sternum, while our goal was to use our knowledge in cybersecurity and research and to create an holistic cybersecurity solution to protect devices, especially devices that impact human lives. For example, medical devices, industrial, everything that has a meaningful impact. But now we really find ourselves that there are many devices connected, and so much of them affect our lives in a way that we don't know because they are just out there. Everything functions. The trains, the lights in the road, everything. So everything is connected now, and we are working to protect those devices and also to monitor them.
Okay, thank you very much. So I'm wondering, what are the biggest challenges that you encounter when monitoring such devices that are out there in the field and accessible to everyone?
Sure. So I think the obvious answer is that embedded development is hard, really hard. I mean, it's not like being a Python developer or things like that. You need to focus on actually making sure everything works. Just once, not even executing your code. So just setting up the environment is very complicated. So I think developers are very scared of changing anything, especially if it's a third-party software. So I think the first blockage is the education, like getting trust in third-party components that the developer will embed. But after you pass that, you have a lot of technical issues where you have communication bandwidth limitation. You have, for example, I just talked with a person that told me he can only send 11 bytes at a time. So that's really an issue when you want to send really a short message that describes something. You can't do it because the system doesn't allow it. But this is an extreme case. Many other systems can, while maintaining low throughput, can send a lot of information, just making sure the behavior is intact. That's another aspect. Another aspect is the hardware. Everything is different in the embedded world. It's not like as standardized as a Linux system. You have different manufacturer, different BSP, different drivers for everything. So a platform, let's say you develop a platform for Windows, for Linux, you can develop relatively one main software that can run on all of them. Mm-hmm. But in embedded, you need to invent the wheel every time. So that's another major issue, where if you develop something, you need to tailor it to a very specific system. Instead, when we designed our product, we wanted to solve all of these issues upfront. We wanted to create a product that can be applied to many systems, no matter which communication channel is used, no matter the hardware. So this is why we made an instrumentation-based solution that will actually work in the binary level. So our only limitation is the ARM architecture for non-Linux devices. Basically, what we do is we go to the lowest level of the software, which is the opcode that the microprocessor runs, and we modify them to embed security. So that way we can actually work on really any outputs, any ARM-based MCU, and so on.
Yeah, that makes sense. I mean, what is this proactive deterministic runtime protection, and what is the advanced threat detection?
Okay, so actually it's very hard to explain. I'm not sure why. I mean, I think when you look on a regular PC, you always install an antivirus. But when you maybe take a look about on a controller that, let's say, manage a bridge that needs to go up and down when the ship pass by, no one thinks about it, right? So it's really, I'm not sure why. It's very not in our mindset, but generally you have a couple of layers of security. First layer is making sure you have a signed firmware that is running. Let's say secure boot. You want to show no one tampered with your firmware. That's the first layer. Another layer, you want to make sure you have encrypted communication channels, so no one could tamper with them, gain sensitive knowledge, things like that. But the last layer is actually ensuring that the software during runtime is safe. Right? You execute code. The device that, makes decision based on inputs it gets from the outside world. So what validates that the device behaves as expected?
Yeah.
So that's the issue. So that's the issue of explaining it. But once you understand it, you see that it's necessary. The advanced threat detection, as part of the runtime prevention that we could give on the device, is based on our cloud platform. Basically, what we do, we allow the user to send a lot of data from the device. And in the cloud, we have our observability system that first checks for anomalies in the device's behavior. This is how we can alert you about maybe a logical issue with the device. Maybe it acts differently. Maybe it will reboot many times. Maybe it will connect to an unknown unrest for some reason. So this is another security layer. But I think the benefit of that is actually detecting many performance issues. So yeah, so you get as a byproduct of threat detection, you get a rich observability system that you can monitor the device for uh, uh, everything they do, and to gain knowledge about how they are used and how they perform in field.
Mhm. Okay, thank you for that. Thank you for explaining the very difficult concept. And now I would like to ask you about the evaluation kit offered by Sternum. So, what is it, and how does it
Sure.
work?
Yeah. Okay. So we wanted to allow our potential customers to evaluate what is Sternum. So I can explain a lot for 1 hour what we do, but I think someone needs to actually do some hands-on playing with it to understand what it does. So this is why we published the evaluation kit. It's a device based on a STM evaluation board that has full firmware. It's an example firmware, not developed by us. It has a screen with many graphics functionalities. Actually, you can play music on it. You can play games on it. You can do a lot of things. It has a VNC server. So what we did, we first deployed our protection on this firmware, and then we also added the observability aspect by we call it traces, sending traces from that firmware to our cloud. So the kit will actually will contain the source code of that firmware, the Sternum integration that protects the firmware, but also an example of the observability SDK that we provide. All of that with access to the Sternum cloud. So you can get a visibility like it's a real device we just developed, and you can understand how it functions.
Mhm. Okay, so the development kit, the evaluation kit, actually has support for FreeRTOS, right?
Yeah,
And how does it really work?
great. So the complex system I just described, it's all run on FreeRTOS OS, and it's serving as the out-of-the-box integration for FreeRTOS. This means we can adjust to your API that is using the communication channels that FreeRTOS can allow you to do. Mutexes, tasks, all of that is out of the box by Sternum. And we have adaptations to FreeRTOS because since it's a major real-time operating system in the field, we see it in many customers that they are using it. So we have out-of-the-box support for that. So this is why we wanted to select such a commonly used outpost in our demo application.
Mhm. Okay. So maybe can you describe some use cases for the viewers to understand a little more?
Yeah. So I'll stay pragmatic and talk about specific use cases. So on the protection side, okay, you want to keep your devices safe. That can be regulated in industries like the medical space, the industrial space, aviation, transportation, all of that. They are highly regulated, and there are a lot of regulation about cybersecurity, runtime security, things like that. That is, I think, the most basic use case. You have to stand with the regulation, and Sternum allows you to do that. Another aspect is actually to protect your intellectual property. I mean, many manufacturers are afraid that someone will hack their device and steal their IP, which they worked for 10 years. I don't know. So yeah. So and like people used to jailbreak their phones, they do it using finding a vulnerability inside the phone software. So using our runtime prevention capabilities, actually the manufacturer gets also IP protection because people cannot jailbreak their device because they are protected. That's one aspect of runtime security. The other aspect is the observability. Well, I think it's very important. There are many use cases like that allow you to gain business intelligence. So let's be specific. If you have, let's say, hundreds of thousands of units in the field that are using battery, and now you can actually, if you monitor your battery health using the Sternum platform, you can predict when your battery will fail. So you can actually estimate how many units you need to manufacture or to fix. So you can prepare to that ahead of time. That's one aspect. You can take it to the business side. You can see which territories you have less sales cycles. You can see that you're not selling in specific territories, so you can take business decision to increase marketing in a certain area of the world, for example. So using that observability, you can really create both business insights, but also insights to the developers to make them build better products, to release fixes. You can monitor your errors in field. You can see basically what is the most painful parts that your users suffer from, and you can address them using the monitoring.
Mhm. Yeah, no, that's really cool, and I'm happy that you brought the topic. You nicely went from security towards observability because now I would like to ask you more about observability. So, what are the metrics at device level? What are the metrics at fleet level that we can track?
Sure. Okay. So the Sternum observability SDK is very flexible. You can use it to many use cases. I can talk about some of them. So the battery health, for example, battery capacity is one use case. You can monitor your memory consumption, which is pretty basic, but it's something that not many device manufacturers have. They don't know if their memory consumption is behaving as expected. Another aspect is error monitoring. So if you have a critical error, like disconnection error, disconnections from Bluetooth, disconnections from Wi-Fi, maybe actually if you see a device that's supposed to communicate but does not communicate, that's another metric that we track. So, and I think the problem is that you can track a lot of data, but then you have, I don't know, hundreds of thousands of devices. Someone needs to understand what they do, and someone needs to learn or to create actionable insights from the data. And this is where I think one important secret sauce that we provide is lies, because we have our anomaly detection engine that will let you know if there is an issue. We will let you know and focus where you should look and not just collect a lot of data and then be swamped with it.
Mm-hmm. Okay, so in terms of the actionable insights, then you provide is it coming in the form of a dashboard or
Yeah, sure.
okay.
So it's a customizable dashboard. That's one part. But another part are actually anomaly events where you can investigate.
Mm-hmm.
So you can drill down from a huge fleet. You can drill down into a specific device, see what they did in the past hour, and investigate what was wrong in that. What went wrong there. So that's one aspect. I think when you talk about actionable insights, then the battery prediction and the BI use cases I mentioned were actually they are actionable insights. But other actionable insights could be to see how your hardware behaves in areas you did not test it before. And then you can make future hardware decisions if you can change your communication type because you see it's not working properly in some areas of the world. You can change your, let's say, sensor that you rely on because they see they don't work in a humid environment, which is relevant in some kind of world. So there are many actionable insights. I think it's sector dependent. So on the health industry, there are some kind of action. In the industrial, it's different. And we have that knowledge per sector, so we can help our clients focus and tailor the observability capabilities they have.
Yeah, no, that makes sense, especially with devices being out there in uncontrolled environments and totally different than the lab. You've been testing them, and yeah. So, I mean, this is really, it's been really great. And now maybe as our last call to action, let's put it this way, where can developers get started? Where can they get information based on how advanced or beginners they are, with a level of experience?
Yeah, so I think the best way is to use our evaluation kit, and that you just need to browse to our website. You can click on the Get Free Evaluation Kit there, and then you can just experience the system end to end. I think that's the best way to do it.
Okay. Yeah, so probably our producer has already shared the link with you all. So if you have any questions, please put them in the comment section and we would be happy to take them. And of course, if you are watching IoT Builders, feel free to watch the episode we had with Natalie, the CEO of Sternum IoT. It was a really good episode, very insightful. And yeah, I'm happy to have you here.
Thank you. Thank you for having me.
Yeah, stay tuned, IoT Builders. We are going to be live next shortly.
Thank you.